This is G3f, and we're talking about know, prove, and apply basic theorems about parallelograms. So I have the state of Washington's list of theorems, and here is everything that you need to know for the end-of-course assessment with regards to parallelograms. So this list, there's 7 of them altogether. Take a good look at them, and I'm going to show you a couple of different types of problems you might be given, and then at the end we'll refer back to this again. The first type of problem you could be given is to find a side length or an angle measure. So for instance, we have something here that is a parallelogram. And so you need to know all of the properties of a parallelogram. And so for instance, in a parallelogram, opposite sides are parallel, which means this is a transversal, which means this angle and this angle are congruent because they are corresponding angles. And so if you were asked to find the measure of this angle right here, the answer would have to be, well, let's see, 110 plus that angle has to equal 180 degrees because this is a straight line, 180 degrees. And so hopefully by now you're figuring out, well, the answer has to be 70 degrees. So finding an angle measure or finding a side length is one type of problem you can face on the end-of-course assessment. Let's take a look at the second type. So this is the second type of question you could see on the end-of-course assessment. Up here in the top right-hand corner, I have what looks like a rectangle, but is actually a parallelogram. And I have the side lengths in here, 3, 4, 3, 4. And the question is this is a parallelogram, but is it any other special quadrilateral? Is it a rhombus? Is it a rectangle? Is it a square? Is it any of these other ones? Well, if you draw in the diagonals here and here, that would make 2 triangles. One triangle would look like this. So this is 3, 4. Oh, and this one would be 3, 4. And so if you look closely at the rectangle at the top, this side would be parallel to this side, which means this angle would be congruent to this angle. To transfer that down here, that's here and here. And then secondly, this side is parallel to this side, which means that this angle is congruent to this angle, which would be here and here. And so we can prove that those 2 triangles are actually congruent because of SAA, which is a valid shortcut. It's in the theorem list. I can use that. And so because the 2 triangles are congruent, that also means that the diagonals are congruent. We can say that so because of corresponding parts to congruent triangles are congruent, CPCTC. And then you say, well, what's the big deal? Well, if you have a quadrilateral and the diagonals are congruent, that means that it's also a rectangle. So I pulled up the theorem list here, and here it is right here. A parallelogram is a rectangle if and only if the diagonals are congruent. So that example that I showed you kind of has to do with proving one of these, or maybe applying one of these theorems in the case to show that it's a special quadrilateral. So definitely spend some time and know this list of theorems, backwards and forwards, and I think you'll find that it'll be pretty useful once you get to the end of course assessment.